is I'm cutting joints where I need a hole to fit another piece into. So cutting square corners, you have to like do the little dog bone thing.
Yeah. Yeah, the dog. Yeah, unfortunately. Yeah, it matters for the inside or outside cuts. Yeah, that's fair. And then I have problems when I'm trying to get like two pieces that I feel like I wish I could stack them on top of each other, but I can't securely, like if I'm trying to do the same thing. And I get it, you can just run two times or whatever, but I don't know. There's certainly a time and place for the laser. That's for sure. And the lasers are so much quicker. So
Yeah.
all right. We'll get started. Plenty of time for chit chat. Looks like we got, I don't know, 10 people or so online, somewhere in there. Good morning. I'm sure more people will filter in, those are the words, as we go. My name is Chas. Today I'm hosting because Lloyd is out or playing hooky, hanging out with his wife. Maybe they had a long Valentine's Day. Hopefully you didn't forget that one for your loved one. So let's move along. This is our typical meeting agenda here, right? We're gonna welcome you. Welcome. So that's done. We'll talk about some club business events of note. I don't remember if that was in there. Don't remember seeing that. Today's we'll discuss today's presentation and what's coming up. Just kind of introduction. The Robothon updates from the committee. We'll do the around the virtual room. So save your sharing for there, right? That's up in 15 minutes or so. And then if there's any other items, I think he provided a couple of YouTube videos to discuss. We'll have like a, I don't know, 5-10 minute refill the coffee break or so. And then we have a presentation, looks like. I'm guessing at least Chris is on, so I'm sure other people are there too.
I told them that they didn't need to be here until a little closer to 11.
No problem.
I've got a
right.
little 5-minute introduction deck to get us started, and then we'll turn it over to the students when they get here.
Perfect. Right on. Yeah, certainly don't need to be here till 11. So right on. Thanks, Chris. As always, I encourage you to come off mute, ask questions, stop me, tell me that I'm speaking too quick or I use an acronym you don't understand. Something like that. But particularly if there's a lot of background noise, click mute. I don't really care too much if you stay off mute myself, but if there's a lot of background noise, please do stay muted until you have a question. As always, we encourage you and to use that Zoom chat to ask questions, make comments, post links, any other information, some additional information. Maybe you have like a little bit or a bit of a SME in something. Feel free to drop it in the chat. We actually save the chats and then post them with the YouTubes for later consumption. So your suggestions and links and whatnot will go beyond just the recording today. Oops. In club business, we're always looking for more people to present. I think he's got out to May right now, if I'm not mistaken. We'll see here shortly, but generally Lloyd does the presentations, or maybe Steve. I'm like the backup of the backup guys. Donna, sure she's presented there plenty, but I don't remember the last time I saw Donna, but out of fairness, I don't always attend these. So somebody will host this basically. If you're also interested in hosting, you want to work on your presentation skills or something like that, reach out to Steve. Steve schedules all these things. He actually does all the work of updating these decks. So thanks, Steve. Oops, click. Oops, I went the wrong way. Local maker spaces, this is here because it's a good place to meet other people that have some skills making some stuff, making anything really. Usually you can find some tools, you can find some, if not formal education, some ad hoc information so that not everything you're doing is YouTube University. You can go to the SRS webpage. I've actually never done this. Let me see if I can. We got the time, so I'm going to see if I can drag this on top of this. So if you go, oh, that's Robothon. If you go to, what did it say? Resources, makerspaces. So if you go to resources, you can go to makerspaces. Looks like we got a bunch of makerspaces. If this list is not complete, drop a link in the chat and we'll ask Steve to update it. So Oli Mega, they've been around for quite a long time down in, and actually I've noticed on Meetup they actually are having a lot more workshops lately, which is great. Down in Olympia, if you're down that way, there's the library system has a makerspace in Federal and Bellevue. It looks like Lacey has a pretty solid makerspace way down there compared to me, anyways, or in relation to Seattle. Fab Lab Tacoma, it's more like you bring your thing there and they'll build it for you. But if you need it, they're there. Maybe they've started doing something different, but there's a Creation Station, another one, Tacoma, Burien, South Seattle. Korea is no longer in existence. Kind of a bummer. We were just talking about that. So we'll have to remove Korea or however they named it. It's the renting makerspace. There's Alt Space in Seattle, Seattle Makers, who just recently moved, if I'm understanding correctly. The North End Makers are Clanlin Shoreline area, right off 499. Oh, yeah, they have a note. They have a 3D meetup the first Saturday of every month. Okay. I don't know what that means. Maybe 3D printing meetup, but Mecha Spark. Ooh, I didn't know of this one. Kind of cool. There's one in the city of Auburn has a makerspace. I believe you may know this one. That's kind of funny. Snowco Makerspace in South Everett off Airport Road. The Creator Zone, which is kind of cool. Now we're getting too far away. That sounds like somebody who lives in the South End. This is in Lake Stevens. It's a little bit more geared towards children, but really great if you have like a child. I mean, certainly a good place to go though. Bellingham Makerspace is probably the biggest makerspace by volume. They're in the mall up in Bellingham. Yakima has one. Richland, if you're over there. Portland, there's kind of a couple down in Portland actually. And then there's the barn. I think they were supposed to do a presentation for us once, but they've been around for quite a while too. It's I don't know if it's considered a makerspace or not, but yep. Someone was just off mute for a second. It's fine. All right. So there's that. And you can go away. So I recommend makerspaces just because it is a good place to get inspired to learn some stuff. And it'll help motivate you build that next robot. There is, well, right where we were looking, there's robotics event site. I guess we put it on there because there's so many now. So just go to the website, same basic area, except for you chose robotics instead of makerspaces. For meetings, there is actually more than just the Sunoco makerspace. I think it's the only in-person one. I could be wrong. Maybe technically, I think Seattle Makers has one too. So the meetings for Sunoco Makerspace are in person. They're the first Saturday. So, every other Saturday, make Makerspace fun. I think like the second Saturday is the Vancouver Club. There is a lot of Zoom, other opportunities to talk about robots. So it looks like there is an ask here if there's an interest in another virtual Robothon exhibition. If you never watched them, we did them during COVID. And it was just kind of I think there was like two types. There's one where it was like kind of a present your robot, maybe make it move around or something, or just talk about it. And then there's another version, and I don't know which one Donna might be talking about if she's on. She is not. Where we actually, have robots at a certain location and we just put it on Zoom and they compete or something like that. So I don't know if there's any interest there. Anybody want to talk about that real quick before I move on? Okay, just throw it in chat if you're interested. Come on. Robothon committee. The Robothon committee just met this week. They're pretty much all set. We got to do some final checks, make sure that we have the right tables and the right chairs and everything set up. But the spring event is coming on May 31st. The spring event is inside the FIRST Field Clubhouse that's down in, I think it's considered Kent. somewhere in that neighborhood, maybe Tukwila. I'll probably Tukwila actually now I think about it. But anyways, it's down at the first building. It's where we had it last year if you went there. I'll talk about it just a little bit more in a second. You know what? I'm gonna talk about it now. I'm gonna take this back over here. If you go, and I'm sorry if there's another slide on this, we need to skip it if there's. If you go to the robothon.org website, it's up now. You can actually sign up now. So you can go and you can look at past events, but there's an announcement Donna put on here for our event. It gives you an idea. There's actually a couple more contests this year. So if you have an old one, an old robot that you used to compete with, and you're like, why aren't they doing line mazes or maze following, wall following, whatever. There's a couple contests that we haven't had for a while. So take a look at it. These are all robots that are, I mean, they can be extremely complex, but they're all very easy to get started in on. So I encourage you to take a look at this. Line following, line maze, the SRS build challenges #1, which is that 15-foot indoor square. They're all the indoor ones, right? Mini sumo, which we did, and I think there's there's a presentation for a 3 kilogram sumo to muster up some interest in that one, and the pop can challenge, which is also the indoor wayfinding. You can sign up now. I encourage you to sign up even if your robot isn't completed, right? So you just go like, I know how to type today too. Chance@gmail.com. And then, yeah, you don't get my phone number, but oh, I have to give it to them. But pop bot 0.4, it's going to be line following. I'm just going to give them a fake one because they know it anyways. And you submit. So just it doesn't take you very long to sign up. Even if you're not 100% sure your robot's going to go, I still encourage you to sign up. Get your pop bot or get your robot signed up, and yeah, I mean, if nothing else, it'll motivate you to work towards that goal of being done in time. Details to follow. Visit robothon.org. Just I mentioned, we are going to have again that fall October event. There's discussion about a walk your robot in the park event that probably the Snowco people will do. And then maybe another one in the north end, kind of up by not quite Bothell, but Lake Forest. So there is a new SRS related meetup group. So this meetup is let me click the button. Did it not go? No, apparently it didn't. We have to do this. Open a new tab. Lovely. Sorry, slideshow. I have to start over. No, thank heavens for that. I'm just gonna go meetup. So I recommend you take the time, meetup.com, log on. Meetup is an event website. It's perfectly safe to sign up on it. I've been on Meetup for 10 years. It's a great way to look for things to do around your area. Oops, I want to go to my groups. And so like there's a Vancouver's Robotics Club. You can see their events, if you want to know what's going on. There's our SRS group. There's just a bunch of different groups that you can join, and they post their events on this. There's around here, tens of thousands of events. So if you go to Build It with Arduino, you just search for Build It with Arduino, or I'll drop the link here in just a little bit. You'll see it's organized by Donna and Steve. And the idea is that they have upcoming events, and it gives you all the events you need to know. Wow, 33 attendees, good for Donna. So that's just the people that RSVP that they're coming. And there'll be a link in here somewhere, I'm sure. I just don't know where it's at right now, but take a look at it. It's probably in the details I didn't look at. Or shouldn't have a link. Maybe she posted it. Oh, I haven't RSVP'd, so I can't see the link. That makes sense. Anyways, go there, RSVP, take a look at it. They're all Arduino based. So that idea is like if the hardware is fun and you feel comfortable with putting wheels on little shafts and building little things, but that programming is pretty intimidating, which it can be. You know, she's launching this whole new series to help people build their skills with Arduino, not necessarily robotics related. So looks like the first meeting is next weekend. So, for the QR code, if I'll leave it up for a hot second, if you want to scan it with your phone, you know, you open up your camera app and it'll give you the link. And I'll also, sorry, right click on this and I will copy the link so I can put it in the chat. See the chat. Paste. There. All right. Next up. Looking for presenters. We don't have a whole year of presenters like we normally do. I think we're actually kind of short. Only got a couple months out. So if you know anybody that might be interested in presenting, or if you're interested in presenting, maybe even if you're not very comfortable reaching out to the person that you would like to see a presentation from, email the Seattle Robotics Society at gmail.com. Include any correspondence you have, DC people that you talk to. But I would also suggest that you consider presenting on one of your projects. It doesn't necessarily have to be like the robot that rolled around on the ground. Maybe it's just some sort of like vision system, you know, like Bob did a really excellent presentation recently on just, you know, a portion of a robot, but just something, you know, in the realm of, you know, computing, mechanical engineering, whatever. So you can also lead a facilitated topic. So we even have a couple topics in the old pocket if you're like, hey, I'm willing to do one. Just, you know, what kind of topics are there out there to discuss, or even go over like a YouTube video or two, and you know, have like a presentation. So please reach out to Steve at the that email address. This is an open discussion forum. I think it's here just in case we are staring at each other and don't know what to talk about. I don't think that'll be a problem because I'll just play YouTube videos. And then here's our presentation plan for this year so far. Today, well, actually, I'll mention that in a second, so we won't talk about today because I think there's a slide on it next. Next, and it's tentative, the SLU students have a presentation for the robotics project. I don't know what that looks like. John Davis is going to do more on AI. He did last June, he did an original presentation. We do have a YouTube channel that's on if you want to go look at it. So he's got some more. This says that I'm doing the Aloha robot, but it's actually a guy named John something. I can't remember. I should know. I just don't remember. But a different guy, as I just recommended him because Joe, sorry, is Joe. He spoke up last meeting or the meeting before. So he's doing that May 17th. I'm doing one, I think, in June on Node-RED. And then you see we got a lot of open. So, and that is a very sensitive mouse. As always, we have a post-meeting general robotics discussion after the presentation. It's not recorded. I just turn off the recording and general talk. So let's see. This is coming up later. It's the Federal A First Robotics team. Is it Saghalie? Sorry, I'm sure I pronounced that wrong. But anyways, they're gonna do some presentations on their robotics. So, or that will be at about 11 roughly. Quick review for next month. We are gonna do the same thing next month, just different presenters. And then we're going to do around the web here. So as always, we have a couple of YouTube videos to share. If nobody has anything to share, we run out of stuff to talk about. I got like maybe I have 1.5 things to talk about, if that, or I have a bunch of videos. So before I start, I will give somebody else the opportunity to come off mute, share, ask a question, give us an update on where you're at on something, seek advice, etc. Okay, well, I'll start.
Hey, Chaz.
Yes, sir.
We have another event that we're in the planning process for, and I'm going to put a link to it here. It's the Northwest Hobby Model Expo.
Oh, thank you for, yeah, that didn't make the slide deck. You're absolutely right, John.
Let me see.
Yeah, please do drop that. So the Northwest Model Hobby Expo is in Monroe at the Evergreen State Fair. It happens usually once a year. I've seen it happen twice. It is a really fun event. I've been to it almost every single year for the last, I don't know, 8 years. There's a couple things there. One, the War Robot guys show up and they do their sorry, I should back up. I think he's going to post a link to it, and it's a 3-day kind of event. It's Friday afternoon, a Saturday, and a Sunday. The War Robot guys do their competition, so it's kind of fun to watch that, and it makes a lot of booming noise when a robot goes flying. That's on Saturday and Sunday. There's like RC, it's Model Hobby Expo, so small stuff. There's like the carpet racers, RC car racers. They're in like a separate building. There's a whole bunch of clubs, a ton of clubs that present, on joining clubs. So like there's a model yacht club and a RC boats club and whatever. They have a whole area for people to sell. They're like, like a swap, if you will. It's a swap meet sort of whole building full of swap meets. So if you're looking for parts, electric, mechanical, whatever. That's fun and usually pretty cheap too. But we are looking, I think we're going to bully Steve into it, or Lloyd, I should say. We're going to bully Lloyd into it. I think we got enough people to go. But we're looking at showing up and having a presentation for the SRS there. So sorry, John, did you post that link? I didn't look.
Yes.
Okay. I don't know if I see it. Oh, yeah, there it is. So I think we're looking for, what do you think, John? Another person or two to come hang out with us?
Yeah, we have 4 already, but so it's probably only room for 2 people at the table. But if there's extra people, like that, would be nice to have somebody there as a backup. But yeah, it'd be nice to have more people there. Plus, if you have something that a robot that to demonstrate, or some kind of interactive project that we could use for the people there, that would be really great too. Because the type of booth that we're getting is one that is, what's it called here?
Interactive, I believe.
Pardon me?
Is it interactive?
Interactive, yeah. Yeah.
Yeah, so I think it's discounted because we bring interest, something for people to look at. You're going to find all sorts. Most of the people are from around the area. The maker space that I'm part of usually goes, I don't know that they're going this year. But they also do an interactive booth. But the whole idea is, you have something to show off. There's a ton of people that show up, ask questions. A fair amount of kids, but plenty of adults looking for stuff to do. And yeah, having something interactive is nice just because people get a, look and see, scratch and feel, and they're driven there because they're, interested in hobbies, and this certainly is a hobby of hobbies.
Yeah, so if anybody is interested in joining us there, I think you could probably just maybe it's a way of like communicating without oh yeah, just do a personal chat, I guess, on here and let us know.
Yeah, absolutely. Yeah, I think Terry is online. I think he's been there quite a bit. Terry, you gonna come up and at least say hi? He might be driving. All right. Well, yeah, please reach out. John Jennings, you can message him, you can message me, or you can just drop it in the chat and say I'm interested, and drop us an email address. And we'll coordinate. It would be nice to have, the only reason I say it's nice to have the only reason I think it's nice to have a couple people, even 3 people at a time, is just because one person gets to go look around, go to the restroom, go get a lunch, that sort of thing. So, awesome. Thanks. Terry will stop in. All right. Thanks for that. Appreciate it, John. And it's all John's idea, so blame him, not me. All right. So I would encourage, I brought this just upstairs in my dining-ish nook thing. And I brought this upstairs from my little hobby space just because I felt like demonstrating that you don't need a lot of, this isn't going to do anything, so it's not that exciting. You don't need a lot of money, or you don't need to invest a lot of money into a hobby for something that you're not 100% sure that there's a lot of value other than enjoying and learning something. Um, I know that some of the robots, some people have poured in thousands of hours, I'm guessing, into some of these robots. I know, like, with in the day and age of a lot of work and family obligations and all that sort of stuff, you don't always have that. But you can legitimately go on Amazon or eBay and buy like this little robot kit here. This is the Mecanum robot, I think it's called. Well, anyway, it's got a, doesn't need to have these wheels. I just got this one because I thought it was interesting. They have plenty of 2-wheel drive robots. I think I got this thing. It's all it is a metal frame, right? It's just a little metal C frame. You can see, oop, the camera's there. Little metal C frame, and it's got these cheesy little, yellow box geared motors, which I guess I call them cheesy, but you can find a million of them for dirt cheap or free in some cases if you go to the right free tables. And the whole thing I think was less than 20, if I'm not mistaken. I think it was $19. I can find one for 10 for no without a problem. And I built this thing in I'll call it a long weekend. I decided to 3D print it a base. So I just 3D printed this orange thing that sits on top of its base. If anybody wants an STL for that, it's actually printed in 3 pieces just because I found that easier because I wanted to be able to swap something out of it. It's just bolted down to the original chassis, and it's built to hold the Adafruit Feather terminal breakout board. And this one has an Adafruit Feather, and I think this one's actually an ESP32. It is. Which you could use the ESP32 for remote control. If I'm not mistaken, um, James was part of a club. Probably, I'm sure it's still out there, but they were doing some ESP32 robotics stuff, right, James? I want to speak for you.
Are you
See,
talking to this James?
yes, Newton.
Oh, yeah. So the San Diego Makers Guild,
Mm-hmm.
we did a little ESP32, sorry, an ESP8266 based robot.
Oh,
And
okay.
the key to that was to try to reduce the price by not having to have some kind of a remote control for the people
Yeah.
who were using it. So it serves up
Mhm.
a web page into your cell phone or tablet or whatever, and then that becomes the remote controller was the point.
Yeah, if I've looked at it before, and it looked like it'd be very easy to take port whatever you guys worked on, which was a really cool little remote control idea. It's kind of like a little thumb wheel you just pull, left and right. I really enjoyed that project that you guys worked on.
Yeah.
And yeah, that was you say it was an 8266, right? So really cheap.
Yeah, and there's a ESP32 version of it as well. It's been done both ways. Uh,
Okay.
and then you would port it to do. Sorry, I missed what you were saying about what your goal was with that.
Oh, this is just a dirt cheap rope, you know, chassis. I mean, I think somebody could
Oh, yeah,
take
yeah,
something
yeah.
like this
So
and just build a real, a really easy to compete robot if they wanted to, right?
yeah, and actually, there's zero
Hmm,
porting that needs to be done for that because
hmm,
the way that actually works is it controls 2 servos. So one servo can be the drive servo, and the other servo can be the steering servo. And it
mhm,
turns out that the control works just fine that way because on the right hand side of the screen for the setup that we have, there's a weapons control. And you can just, so that runs a separate, either an ESC or a servo. It doesn't matter what you plug in. So if you plug in a servo there, then that can be your drive servo. So you use like a continuous rotation servo. And then the other one can be your servo for turning the steering wheel back and forth if you want to. And then you can also you can use an ESC and a BLDC motor if you want to. And then if you want to change it back to just running a DC motor, I think there's actually just a config item somewhere, if I remember correctly, that changes it so it'll work with that instead. So yeah, it's really easy to adapt to different robots.
Absolutely. Yeah, thanks for sharing that, James. The whole idea is like, of course, that just makes it a remote control car, a really cool remote control car. But you can build off that. And then if there's an autonomous competition that you want to, you already have, I'm going to call it 80% of your robot code done, right?
So actually, sorry to break in again, but
no, by all means.
There is, okay, in the code that we're putting into the ESP, there is an editor. So there's a JavaScript editor that you can go to. There's an edit button on the control panel. You go there, you're in an editor, you're looking at the files that are on the robot in JavaScript, the ones that get sent into your phone, okay?
Okay.
The C code, C++ code in the robot supports already 3 contact sensors and a ping sensor, an ultrasonic sensor. And it sends that information back to the cell phone every control cycle. So one of the things that you can do, and this is something I have my students do in the class I teach, is you can go into the JavaScript code that's running on the cell phone and change the way it drives the robot by looking at the state of those sensors, which are being reported back to the cell phone. So you can make a fully autonomous robot that runs its code runs in the cell phone instead of running on the robot, but it gets the same thing done, if that makes sense, right? And you don't have to like install the Arduino IDE or do any of the setup or any of that kind of stuff. It's the SD Makers Guild.
It doesn't. Oh, it's a Makers Guild.
No.
Yeah, would you mind?
I'll post a link to it.
Okay.
So anyway, there's a way that you can just do that like directly with zero extra work. One of the things that we had really hoped that we would be able to do is then, because your code is running in the cell phone, you have all of the power of the cell phone. So wouldn't it be fantastic if you could access the cell phone sensors and like do things like use the cell phone camera to send, pictures to that's an early version of it. That's the one.
Is it?
Yeah, that's the one. There's actually, if you go to that GitHub link, the bottom link
down below,
that's
right here.
visible on the page right there, and then scroll down just a little bit. There's all of the information about it, all that kind of good stuff. If you scroll down a little bit more, you'll actually see that there's an edit button there, and there's the web editor and all of that kind of good stuff. So what we found out is that there's a problem with the security in the cell phone browsers where it will not allow you to access a non-secure web page from a secure web page, and it will not allow you to access the phone sensors or any outside resource from a non-secure web page. And making the web pages in the ESP secure is practically impossible. However, if you are using a desktop PC to control the robot, and if you go in and tell the robot what the Wi-Fi credentials are, you'll see that there's a Wi-Fi.txt file on the lower left-hand file list there on that page. If you go in there and put in your Wi-Fi's name and password, and then you access the robot as an IP address on your local network, there is a flag you can put into Chrome that will tell it to treat the IP address of the robot as a secure location, even though it's really not. And of course, this is dangerous and you shouldn't do it because it's bad for security. But in that case, then you can have access to web resources and all of that kind of good stuff. And just, think about the power that gives you. Basically, what you do is you put the cell phone, or actually it would have to be a laptop. You'd have to put the laptop on the robot and it could drive around and then use its own sensors to detect bumps and orientation and GPS and all the rest of that kind of stuff. So anyway, obviously that's not an ideal situation, but it just kind of gives you the idea. And then we're moving on, although I haven't had time to work on it in years. Down at the bottom of that page, I think there's a mention of a blink bot, which is a different thing in the links down there. I don't know where it is. Oh, I didn't put it in there. That's really stupid of me. I'll add a link there to the blink bot, which then avoids this issue of using a Wi-Fi connection.
You
And
did a presentation on it, so
I did a presentation on that. Yeah,
go watch
there's a
that
demo
presentation.
above that of the ping sensor working and all of that kind of stuff. So we've had a lot of fun out of that particular thing.
That's great. Thanks for mentioning it. The point being, you know, if you're feeling uncomfortable with programming, a number of people, you know, like James Newton and his pals, have created some opportunities for you to get into robotics without having to be, um, you comfortable with coding even, or feeling like they can master a complete project. So a lot of opportunities out there. Don't make coding one that makes you feel like you can't participate in the competitions. And again, the competitions are there really just as a artificial time, you know, something to motivate you to get something done in an amount of time. Nobody's out there, you know, really. I mean, I've never walked away once, you know, feeling bad about not winning anything. It's all about just bringing stuff out and admiring other people's hard work and showing off what you did. So, all right. Anybody else have something they want to bring up? All right. I have one more thing to share before I watch some YouTube videos here. I found the need recently to make a metal bracket, and I 100% understand that there are a lot of services now that are really cheap if you can go out and create even an SVG of what you need to cut for a metal bracket. There's a lot of, you know, like Osh Cut, I think is one. There's a bunch of different cutting services for plasma cutting stuff, but that hurts my soul to do. And so I've been working on I had a plasma cutter a couple years ago. Somebody blew it up for me. And I since gave it away to a friend so that he could revive it. And it was just a hobbyist build one. Didn't particularly like it anyway. So I bought a gantry like a year ago. The gantry was not complete. It was like an upgrade kit, which was super cheap, and it was on some special. So I think I bought it for like, I don't know, cheaper than the aluminum seems like it'd be worth. I think I bought it for like $60 or something like that. And it's all 20 millimeter by 80 aluminum extrusion, C wheels, all that sort of stuff. But it wasn't complete at all. It was just like the upgrade kit. So I didn't even include the motors, but I got the motors here between the 23s, separate motors, and I've been building its controller for it. So I look forward to having, hopefully in the next like 2 months, CNC plasma cutter again, and I might bring it and drop it off in the Snohomish County makerspace, the Sunoco makerspace, for people to use. Or even if you guys need something cut, and by all means, you could always just go to one of the cut places. But if you're interested in trying to figure it out yourself, this is just nothing special. It's MakerBase MKS DLC 32 controller. So that's the thing that would take your G code, take your G code stream from whatever G code sender you're using. And then it drives 3 of these like cheaper stepper motor drivers. You drive them with pulses. So you like send a pulse for every time you want the stepper to cog or move direction. As well as an enable disable. So that's in progress. It was way too big to carry up here. But it's a complete frame. The gantry is not finished. And I already had a plasma cutter from the old one. I had to go and spend, I don't know, it was $100 or something on the metal or the machine torch again. But yeah, maybe that'll be something to do in the future. And hopefully I can cut my my own robot parts that I need for metal, because 3D printing is not always the trick. It works a lot sometimes, even in conjunction. If you guys have seen James Bruton's, or however you say his last name, Bruton, his work, he does a lot of 3D printing with extruded aluminum. I use a lot of extruded aluminum as well, but sometimes you need something a little bit more robust for some of your bracketry. It's what I'm working on right now. Fortunately, I should be working on robots, but I got distracted because that's what happens sometimes. So unless somebody else has something else, I'm going to click on some links here. Oh, man, this Apple Magic Mouse, the only thing magic about it is why is it so sensitive? I am going to try to share my audio. Nope, that's definitely not the right answer. This is the worst part about sharing. It's like there's sound optimized for video sharing. Oh, that's the way they did it. So let me click on this, copy the link, drop this here, Control V. Definitely not the right link. Come on, go back. Copy link. There we go. There we go. So this is just looks like ISS flyby. Oh, okay, just kind of a neat one. These are all from Steve. So if you have some videos that you really would like him to show off, by all means. You don't have to wait for any advertising, because life is not right without YouTube Premium for me. So I don't know if there's audio or not. It doesn't sound like it on my side. At low altitude. Oh, I see. Like you could barely see it. Like, it's not going fast. I don't know why. I guess that's just a video of what it would look like if it was flying. Oh yeah, it's Microsoft Flight. Well, of course it's a simulator, but not exactly what I thought it was going to be, although that's fine. All right, my Zoom bar is in the way of me being able to do anything. There we go. With that. And let's see what daily training of robots driven by RL. Copy link here. Anybody wants to interrupt and have something to share, by all means. This one is, I guess that's full enough screen.
How long's it gonna be before those dogs start fighting back?
Yeah, exactly, Craig. Like, why are you signing up to get killed by the robots first?
Well, that's yeah, that's probably not going to happen. Well, it may happen, but not for the reason that people think. The robots
Yeah,
don't
well,
care about being thrown around because they haven't been programmed to care about being thrown around. The problem is that some idiot will program the robot to care about saving the earth, and then we're all dead.
oh, for sure. Well, let's see. Who knows, right? Like, I definitely somebody's going to program a robot to care about being thrown around, and then it's going to teach other robots to care too. And that's when this guy is first to go. So
Yeah,
I'm
exactly.
here to tell you. I'm here to tell you that our Amazon listening device does not care for me at all because I'm not very nice to it. I tell it to, F disk itself and everything. And it won't play music for me. It legit does not like me. I'm 100% sure of it. Anyways, yeah, this guy is first to go, so enjoy.
I see a long apology to your robotic overlords in your future, Chaz.
Yeah, for sure. Well, at least I had a cool carrying handle inside. That was neat.
On this episode of Vice Grip Garage, my son Bentley and I
Clearly, I like that stuff. So, mini V8 engine. All right, I guess. Let's see what the mini V8 engine has to offer. Like we got like 4 minutes and it's break time. Go.
Very nice robot there, Chaz. That is,
Yeah, I know.
for anybody who's wondering, that's how you get enough hydraulic power to actually make your walking robot walk.
What do you think is that a brushless motor on the front of it?
I think that's a magneto, or maybe it's a starter motor.
Oh yeah, maybe. Yeah, it's got a little crank. I guess I could see that. Yeah, absolutely. This is interesting. That guy has more mechanical skills than I will ever have.
I was just talking to a friend of mine today on this subject. I think it's really interesting and worth noting that the amount of stuff you have to get into your head in order to be a high-level fabricator probably is equal to, or maybe even exceeds, the amount of stuff that you have to get into your head to be a high-level programmer. And the reason why I say that is because today we have Copilot and other really not great, but still good AI assistants for programmers. I mean, I don't know about anybody else, but I've been using Stack Exchange and there's this meme about, hey, it's not like you can be a professional and just cut and paste answers from other sites, for a long time. Now with the AIs, it's even better than that. But being able to fabricate something like that, being able to fabricate a robot, how do you cheat at that? I mean, you really have to know your stuff to be able to build these things. And I personally just spent, and I shouldn't admit this because it's really sad, but I spent a month trying to get a tube to go through a set of pillow blocks, through a set of bearings. And I could not do it. I had to reach out for help and find somebody local who was kind and had a lathe who could turn the thing down for me and get it to fit correctly. I could not find any way of doing it myself locally without a lathe. It's just, fabrication is a stunning skill, and people who do it should have more pride in themselves. And I appreciate you. That's what I'm saying.
I couldn't agree more. I reached out to a friend on the later Pop-Out series 6, 7, and 8. I still have it, but I wanted to do four-way steering with my stepper motors and not have those, some wheels with the little, mechanisms or whatever you call them, with the little roller bearings on them, because they were super loud when you're actually using them. I think they're loud anyways.
Yeah.
And they're cool by all means, but so I just could not get a mount that was reliable. I mean, I could do like everybody else, right? I can go to the old CAD.onshape.com, right? And I make whatever I make. Whatever. Like this was a little thing for something for work that I just whipped it out, no problem, super easy, 3D printed it. But 3D printing only gets you so far. If you need something that's robust, won't bend or melt when it's in a hot car, like you can't put your robot in a hot car and drive it across town and expect your 3D prints to not be affected unless you're 3D printing with some decent, better material than PLA. But this wouldn't last, and it wouldn't last outside. And that's fine. Like 3D printing is really easy. But yeah, once you get past that and you're starting to have to machine stuff, I have to rely on friends. Like then he's got lathes, CNC, manual CNC, and like he has all the skill set, all the materials, like and all the tooling. Oh my gosh, buying a lathe is one thing, but getting all the tooling that you need, holy smokes, that's a totally different thing. So I totally agree with you. I think hats off to them. It's something that I know that I don't think I have the time in my life with all the other things I want to do to achieve. I'll tell you what, I'm going to say that we're on a 10-minute break now. I guess we'll call it 11:02. Who cares about what it says on this thing? At 11:02, we're going to hand it on over to Chris. I think he said he has a small little presentation to start the presentation off with, and we'll go from there. So,
Hey, Chaz, I just want to jump in and say that San Diego has a miniature engineering craftsmanship museum. If you want to see a lot of stuff like that little miniature V8, that is the place to go. Absolutely
Oh, yeah?
amazing.
Hey,
Highly
Craig,
is that by Balboa Park or?
guess where I'm going this afternoon after this meeting. I have a friend who came in from Vegas, and I was like, dude, if you're here, you have to come and see the Craftsmanship Museum. It is amazing.
Absolutely.
Sorry, Chaz, ask your question.
No, it's okay. I was just asking him where it was at in San Diego.
It's in Carlsbad.
Oh, okay.
Right. It's on the kind of the eastern side of Carlsbad, so it's kind of near the western side of San Marcos.
Gotcha. Yeah, I lived in Tierra Santa for a number of years. So I know.
Okay, so this is
Carlsbad.
I don't know, like 15 minutes or 20 minutes north, and then like 15 minutes
against the coastline
west. Well, it's inland from the coast, but to get there, you kind of have to, you go up the 15 and then you go over on the whatever. Cool. And yes, in California, all distances are time.
Yeah, for sure. Nice. Yeah, I'll check that out. I go down to San Diego at least 2-3 times a year.
And you haven't come for a visit? Let me know next time.
I will. Yeah, I definitely will. I'm sure I'll be there in a couple months. So gotta go. I'm the Kool-Aid man. I just drive, fly around telling people to drink my Kool-Aid. Like, you want to adopt this process or product, whatever.
I don't know about that one. That has a bad connotation these days, but
it does have a really bad connotation. I don't tell them that. I just think that.
This isn't being recorded, is it?
Oh yeah, it definitely is. But we're not going to allude to what we're talking about.
That's hilarious.
Steve, edit that part out.
Yeah,
all right.
It's good Kool-Aid. It's not that kind of Kool-Aid. It's the good kind of Kool-Aid.
It is the good kind of Kool-Aid. I don't even know if you can buy Kool-Aid. We're not doing any more presentation. We're just breaking. So Hopefully you're using a restroom or something right now. I think it's hard to find Kool-Aid. I don't know if you can find the packets still anymore. We got like the little squeezers and they're a little expensive. I remember it used to be dirt cheap to get Kool-Aid.
And Tang. You can't
Yeah,
find Tang anymore, right? I grew up on
right.
Tang.
And like it's a
Nothing.
5-pound drum, right?
And nothing's wrong with me. Twitch. Ovaltine, my wife just mentioned. You can't find Ovaltine these days.
Yeah. Yeah, the only cheap thing to drink is water now, unless you live in California. Sorry.
That was good.
Yeah.
Yeah, we went, I don't know, 5 months with like effectively zero rain. And then we had
Yeah.
2 inches of rain. 2 inches of rain over the last 2.74. See, we get into the points down here.
Yeah. Every
Over the
point
last
counts.
3 days. So seems it never rains in California, but when
Yeah.
it rains, it pours. Wow, you could write a song about that.
You certainly could. I was doing a job for Caltrans down off the 8.
Mhm.
And we were down, like they have a little central plant down there and everything, and I was helping out with server replacement or something like that. And they it was the evening and it started raining heavy. And as you well know, like it just, there's no place for the water to go, it seems like. And
Right.
they
Right.
shut down like 163 or something like that. And
Yeah.
and of course there's like abandoned cards on the side of the road and everything. And I'm just like, it just rained. But it creates
Things
some
that you
havoc.
guys in Seattle wouldn't even notice bring us to a full stop down here.
Yeah,
And that's not even talking about the cold.
for sure. I think it was a June gloom event. Oh yeah, good idea, Colin, for sure. If you had to, Colin recommended dropping a pack of ice in the container holding the print. I think in hot car, I think you're alluding to, which absolutely. Yeah, and I mean, if you put it like in the back seat and it's not super hot in the car or something like that, it'll be fine. But if it gets the full sun in the car, it's not lasting. So unless, there's a lot of exotic stuff out there to print with. I mean, PLA is just the easy button, but there's a lot of cool stuff you can print with these days. I mean, I say that, but like these last like 6, 7, 8 years.
Most people who I know in the 3D printing area tell me to start off with PETG. They say it's even easier to print with than PLA, except sometimes you can get stringing with it if you have a bug cable, but generally it's pretty good and it's cheap and it's very strong and it's very effective. And then a lot of the like Prusas and stuff like that, the cost of doing nylon impregnated, carbon fiber impregnated nylon has really come down to a point where it's like doable. And that's really, really amazing material. It's not stiff, but it's extraordinarily strong and it won't melt. And on the subject of melting things in a car, there's a activity that we did with hundreds and hundreds of kids where we make what we call glowies, which are like an LED with a coin cell battery, but they're stuffed into a little piece of milk white plastic, which is called Instamorph, but it's basically a low temperature thermal plastic. And what's cool about it is it's very insulative properties. So you can get it hot and melted and then hand it to the kid and they can hold it in their hand without burning themselves while it's still like the consistency of a gummy bear. And so you hand the kid this little blob of plastic and they can push it into the mold of their choice. And then they push an LED into the back of it. And then once it cools down enough, they walk away with this little glowing shape. It's a cool little activity. And I kept trying to tell the parents every single time, watch out because if your kid leaves that in the car and it melts into the carpet, you are never, ever, ever getting it out. It is just not happening.
I bet. Yeah, I'd say we'll let take over here in a sec. Yeah, I always tell people if your 3D printer less than $300, you should probably stick to PLA. But all the new ones now, it doesn't matter. They're really great now. The technology has come along so far. All right, I will mute myself and presenters take over whenever they're ready.
Okay, thank you. I am kind of the least part of this presentation, and so I will do a quick little introduction slide set and then turn it over to the students and the faculty advisor for the club. So this is the TAF Saghalie Robotics Club. And TAF Saghalie is a STEM-focused project-based learning school in the Federal Way School District, serving from grades 6 through 12. So in addition to other STEM kinds of classes, there are robotics classes that Sam Rise is the teacher for, and he's also the academic advisor for the Robotics Club, and he's online with us today.
Hi.
The Robotics Club at the school participates in the FIRST Tech or FTC level of academic robotics. So this is sort of the midpoint between the Lego Robotics and the FIRST Robotics Challenge. The organization provides the structure for the specific tasks that are associated with the robots in each competition season, the leagues, all of the rules and volunteer infrastructure to be able to run the competitions that they have. The pictures here basically show the competition that we did this most recent competition season. It was called Into the Deep, and it involved tasks associated with being able to take small objects, which are the blocks that are in the upper right-hand corner, and either putting them in the baskets that are in the corner on the top left, or hanging them from bars on the infrastructure, the superstructure in the middle of the arena. And I'm sure that students will be able to answer a lot more questions about that when we get to them talking. This is the team, and they will introduce themselves once I'm done talking in a minute. And in addition to the team here in the front, you can see the Makerspace lead person hiding in the background. They are also wearing the shirt. They do have a Makerspace as well as the Robotics Club and robotics classes at TAF Saghalie. And then finally, here's the robot. And this robot is doing 2 of the tasks that are associated with the Into the Deep competition from this year. So on the left, the robot is hanging the blocks, which they called a sample, on the bar. And on the right, the robot is dropping the block into one of the baskets. And that's all I really need to say before I turn it over to Sam. And I don't know, I saw Kai, but I don't know who all else might be on there to introduce themselves.
Awesome. Thank you. Yeah, I'm Sam. I'm a robotics and computer science teacher at TAF Saghalie, grades 6 through 12. And then I also do the after school robotics club, which is the students that are here. And then we take the robot and compete in the FTC tournaments. We'll have 3 tournaments a year, 2 qualifiers, and then like a super regional. And the teams that do best in the super regional then move on to the state competition. So I'll let the students take it away. We have 3 students with us today, and I'll let them introduce themselves, and they can talk about the robot and the competition, and then they can take any questions that you might have. So Luis, you want to take it away?
Sure, absolutely. Hello, I'm Luis, and I'm the TAF Saghalie Robotics Club member. I am personally a coder, and also a driver during the robotics tournament. And during the games, man, there's a lot of stress, but I feel we did pretty well.
Okay, and Kai, you want to introduce yourself? Assuming you can come off mute here. Kai's mic isn't working. Can you tell everyone about Kai if he can't get off mute, Luis?
Absolutely. Kai is the main builder in a robotics club robot, and he is also a driver. So both me and him cooperate the robot. One of us uses the arm and the other one drives. I personally moved the robot while Kai was the arm.
Okay.
And
Okay.
we have to communicate well.
Okay.
There's Kai.
Okay, sorry.
Hey.
It kicked me out. So can you guys see my video?
Yes.
Yes.
Okay, good. So yeah, my name is Kai. I am one of the people that built the robot, and I also control the arm of the robot. If Luis controls the wheels and I control the arm. So yeah.
Thank you, Kai. We also have Jackie here, if Jackie can come off mute. Oh, hello. There you go. Oh, off. There you go.
Hello, my name is Jacqueline, and I'm part of the robotics team. And what I do is that I'm the human player in the tournament, and I also help out designing the robotics book, stuff like that. And what else do I do?
And you also help design the logo and stuff too. Don't forget about that.
Yeah, and I helped out designing the logo as well.
And then we have a few other team members who weren't able to join us today. Aaliyah, she was the human player, or no, human coach. Jackie was the human player. She like gave the robot the samples as needed. And Aaliyah was the coach telling the drivers where to go during the competition matches. And then Ona also came to some of our tournaments, but isn't here today. And then a few other just like students who showed up from time to time, but weren't really like super active team members. So why don't we talk about like what the robot does well and what you guys scored on in the tournament?
All right. Let me take this one. So originally you see the way that we're putting the yellow thing into the basket. That's like the primary way of scoring points in the game into the deep. So we made that arm to try to be able to just pick up the pieces as easily as possible and put them in the basket. But during the first tournament, we found out that it was a lot easier, and we had the perfect size arm to just be able to put the specimens, which in the left picture, you can see us hanging a yellow piece attached to a clip, and the clip goes on a bar, and that scores more points than the right picture does. So we turned our strategy to just focusing on scoring those specimens. As we had a pretty good robot. It was almost like it was like streamlined for it, you know. And as the tournaments went on, we just found ways to make little improvements to our gearing system, to our wheels, to our arm, all that stuff. Yeah.
Very cool
would say
robot.
with the-
What do you use for software to control it?
Luis?
Software, so for our coding, we use a little driver station and a control hub, and we use block code to operate the robot's code.
but you can also, I know you can also program it in, like, I think it was Python, Java, stuff like that. So
Yeah, it did have a typing section, but we
yeah.
don't really use that.
So blocks is a drag and drop language that's available with the brand of computers that are available on FTC robots. And underlying the blocks language is Java.
And Luis,
so
you can
this,
talk about autonomous versus teleop too.
Oh yeah. So during autonomous, we originally planned to do a sort of intricate autonomous, but then as we went on, we realized that since not many teams have the greatest teleop, we would probably interfere with theirs. So we decided to eventually just stay simple with our design and teleop, and we strafe to the right, and usually that works well with almost every single team we have out there. And I would say for autonomous, I would say, well, we have to manually control it. So there's 2 players per robot usually. I was the wheels and Kai was the arm.
Okay, so let me just clarify this a little bit. During the game, there is 2 main periods of play. The first 30 seconds are an autonomous period, in which the robot only is allowed to move via like pre-programmed instructions. But after those 30 seconds are up, you get to control your robot freely with some controllers. So that's what he's talking about, and what autonomous and teleop means.
So to answer the question in the chat, strafing to the right just means that we just move sideways until we eventually hit our desired destination. What you can see on the left image is that little blue taped area, and we start in the middle of the back of our section, and then we just slowly go to the right as the autonomous timer winds down, as the robots control themselves, is basically what autonomous is. So when that time period ends, autonomous mode shuts off, and then we get a 5 or 8 second grace period, I believe, where we have to switch the settings from autonomous to teleop, which just means it's human controls. So during that time, we are not allowed to touch it other than to turn it on, or if it moves by itself, you are not allowed to turn it on until the official timer begins, and then humans control the robot, and which is when we start trying to score our goals, which is usually just by hanging on with the little clips.
Luis, why did we decide to strafe into that taped off area?
Yes, because it gives us a good amount of points, and I would say that other strategies of getting points is, I feel like, too much of a time wastage when we could otherwise be improving the robot itself sometime.
What types of sensors do you have on the robot?
Okay, so basically, you see, if you zoom into the picture on the left, you see like a little black box sticking out the front of the robot. That's a motion sensor, and we were originally going to incorporate it into our autonomous, where we would be able to hang a specimen. It didn't really. Well, we were working on it, like, during the season, as the season went on, and we didn't get far enough in the season to probably finish it and finalize it and make sure all that works, because it's really finicky. When we were testing it, it would the same, if it worked one time, it might not work the next time. So it's a hard process to incorporate those sensors. And as for the question in the chat, the human player is allowed to put, like, you see the little yellow thing that we're hanging? It's allowed to put it's allowed to put those in the game arena, and also clip the black clips onto them. So that
You
just
are also not allowed to move the little block. So the robot usually drops it off into that blue taped area, and per game rules, we are not allowed to touch the block if the robot is also in that area. So usually we have to scoot our way out, and then the human player either connects the robot, or sometimes if we fail to grab the robot correctly, we often just slide backwards, and then the human player has free reign to control whatever's inside. So if it's on the ground messed up, they could just quickly grab it and then place it back to try again.
Okay. We've got some questions in the chat. The first one is, are all the robots in the competition using the same kind of mechanism wheels, or did we choose these? So to answer your question, there's a few kinds of wheels that are legal. So in the rulebook, they just have a list of wheels, and we just picked them out from the list, and yeah. And there are design constraints like height and width. I don't think there is one for weight. There might be.
Not this year. Some years there are.
Okay. Yeah, some years. But it did play a part in our design, because we had to make the chassis like smaller than the
Lighter.
robot and account for the wheels as well. So, yeah.
Do you remember your size dimension constraints? Do you remember exactly what they were?
I think it was like 16 by 12 or something like that. I'm not sure. Okay, another question. Please explain the gears driving the arm and how the gripper is driven. I am the professional arm gripper driver in the team, so I'll take this one as well. If you Chris, could you zoom in on the arm gears? Is that possible?
Unfortunately, no, I can't really zoom in
Darn.
on a slide. Sorry.
All right,
Yeah,
so I
we
guess
can mouse around it.
you guys are gonna have to zoom in. But basically, so the gripper is driven. We have two like controllers, game controllers, and one of them uses the joysticks to control the wheels, and move the robot around, and the other one uses the directional pad to move the arm up and down, and the buttons to open and close the grippers. So that's the one that I use, the last one. The gears driving the arm, there's two motors. As you can see, yeah, Chris has got his cursor over it, and they just move the arm up and down. As you can see, the gears from the two motors are connected to a bigger gear, which moves the arm up and down. And the gripper arms, the gripper clutchers on the end are operated by two servos. So yeah.
Would you like to talk about why we have two motors on the arm at the elbow?
Yeah. Oh yes, that's a great question, actually. Well, if you see the hook on the arm, if you get extra points if when the time runs out, you're hanging from a bar. So, we attached a hook on there to try to be able to get our robot to hang from the bar. And we did come very, very close. Eventually, we realized that why it wasn't working was that we needed more power in the arm. So we attached a second gear, and that it's so I think it worked one time, but
worked really well one time.
it worked really well one time, and
I think
it
maybe
didn't.
twice.
It never worked again, which it was really weird. But yeah, we just decided to keep the gear on because also let the arm move faster, and yeah, and you can have how many motors? Was it like
8.
8 motors, up to 8 motors. So the more motors, the merrier. Yes.
Did you guys design all this year, this school year, or can you
No.
reuse part of it?
Yes.
Yeah.
Wow.
You know, it
I
it
believe the
iterated
wheels
itself.
transferred.
It iterated itself as time went on, but
Yeah, we put those pulleys on the mechanism wheels right at the end there, and those worked a lot better.
oh yeah, they made it so much smoother.
Like
8
butter.
motors on the entire robot, or 8 dedicated to the arm. 8 motors is the limit for the entire robot. So counting our 4 motors for the wheels, we have 1, 2, 3, 4, and then 5, 6. That's 2 for the arm.
And then servos, you can have 12 additional. I think 12.
I thought it was 6.
We didn't need that many, obviously.
What does a smaller gear do? What smaller gear? You're gonna have to specify which smaller gear, because there's a lot of tiny gears. Smaller gear fixed to the arm. Like inside the arm.
The one in front of the motor, perhaps?
I guess on the left hand, this isn't my question, but I'm going to guess. On the left hand side of the screen, yeah, there's like a little gear that's attached. Yeah, right there.
Really small here. We can't see that drive.
He's got his cursor over it.
To your right, there's also a small gear coming right off the motor, and then the larger gear. They may be referring to that one too. I don't know.
Well, I have news for you. Is there a small gear? Let's you would be correct. See, if you look real closely at the left picture, you can see a small gear that attaches to that bigger gear, and that is the one that moves the arm. So we get as much torque out of it as possible. Another thing we did to make it try to lift up. On the left picture, on the left, I meant the right picture, sorry. Right picture, move down a little bit. Up a bit. To the left a little bit. Too far.
Inside that C channel is a smaller gear, yes,
Yeah.
on the same axle.
Where his cursor is, that's where the gear is. So you were right. There is another gear there.
Didn't work anyway.
Faster arm.
So it looks like some of those gears are being used as flanges to attach the arm to a shaft. Am I wrong about that?
Which gears?
Well, I'm looking at the one that's right flat up against the arm shaft. Yeah, right there.
Oh, that's attached to that smaller gear we were just talking about. You see the big gear moves the smaller gear, and the smaller gear moves the other gear.
But yeah, there's a hidden shaft in there.
Okay, so that's the one that's actually actuating the arm to move up and down. And then on the left-hand side picture, there's a great big huge gear. And then it looks like there's another shaft that goes. So the motor is driving that small gear, and then the big gear is, what is that big gear driving?
There's another shaft, and then it attaches to the other side where the arm is with a smaller gear right down there.
Oh, that's all part of that same drivetrain.
It's all the same gear train. It's all connected. Yeah.
Okay. Lots of gearing.
Yeah, like I said, didn't pick it up anyway though for some reason. So who knows? Robots is hard.
Yeah, we needed
Well,
all of this.
and as somebody who's been working in robotics professionally for a long time, you learn a lot more from the failures than you do from the temporary successes that turn into failures at the very worst time. So it's better to have the failure early on.
Chris made a fun comment that I think I agree with too. He thought he was going to come in and help with all the coding problems we were having, and he ended up having to help more with mechanical problems. Like, you just never know what kind of problems you're going to have, and you just have to be flexible and adapt sometimes.
So just out of curiosity, do you guys have any video of your robot running?
Do we have any video?
I took some video.
We do, not conveniently
Did Ona take
accessible.
Didn't Ona
Believe
take
it's in the Google Drive.
I think Coda took some video too. And I took some
Coda,
video, but I don't have it
Coda, if
ready.
you've got it, I can stop
We can share it with
presenting.
Chris, and maybe Chris can show it.
No, it's like on my phone. I'd have to email it somewhere.
Oh, no worries. I always enjoy seeing these robots slamming around. It's fun.
Yeah, I definitely took some video of our last tournament. That we were pretty successful, I felt, this year. We did a big improvement from last year. Luis, do you want to talk about how far we got with our robot this year?
Oh yeah. So this year I would say we usually had issues during different times, like say in the first game. We did not have a great start, but we slowly improved as we went. And I would say the subsequent match, we had a pretty good start, but we started encountering issues. But I would say this final game, I would say we finally fixed all the issues and we're able to make it to the next round after the 1-1 head offs, and we made it to the second round where we got to pick a teammate.
Yeah, they called it the finals.
The finals there. Yeah. And we made it to, I believe, quarterfinals. Is that correct?
Mm-hmm. And you guys,
Yeah.
those were your best matches too. You got a bad draw for you, and the teams you went up against scored just barely more than you. But it was your best performances were in your last matches, which I always like to improve as the season goes along. You want to get better the more you play, and you guys definitely did that.
Right. And I would say it's a good thing we had issues during the start, because say if we were going perfectly, then who knows what could have happened. So I think we got our best chances at messing up early rather than later.
That's the best possible. That's the way to do it.
Yeah.
Jackie, did you want to talk about clipping on? So we're getting a lot of questions about the human player. Can you talk about what your job was as the human player?
Just to answer that question,
still in the call.
chat.
What?
I believe it was. Sorry.
Oh, Jackie's there now. We're getting a lot of questions about what the human player does. Can you talk about what your job was as human player?
Yes. So basically, wait, hold up. are the blocks called?
Samples or specimens? I can never remember.
Samples before the clips and then
Thank you.
specimens after the clips.
Okay, there we go.
Just call them blocks.
Okay, so basically, what a human player does basically is grab like a sample and then clip it onto the hanger, and like when the robot's out of the zone thing, just like we'll just basically put it on the wall. I don't know what the yellow one really does.
No, that's right. Yeah, so the robot brings you the thing, you clip them together and put it back on the wall. That's all.
Yeah.
Because the robot can't put the two together, obviously.
Mm-hmm. Exactly.
You can see one hanging on the wall in the kind of the back corner where the cursor is now.
What did you use for a microcontroller?
Ty or Luis, what was our controllers we used?
I believe they were just
it was a
Logitech controllers.
Yeah.
I think they mean the board that controls it.
Oh.
First has their own, like the motor controller.
I believe it's called
okay.
Okay. So like the driver hub?
Yeah.
Oh, okay. Well, basically it has, well, they give you like a thing that connects to the control hub, which is on the robot. It's called the driver hub. It runs on Android, and there's like a special app on it that you can connect to the controllers, and that app connects to the robot to control it. And to answer Doug's question in the chat, basically what Jackie does is she takes the specimen, the sample, flips it onto a black clip to make a specimen, and then we have to be a set distance away while she hangs it on. Only the samples come in 3 colors: blue, red, and yellow. There's a blue team and a red team. The yellows are neutrals. The yellows can only go in the box, but the blue or reds can be clipped on and hung on the bars for their team. Does that answer your question?
along with also being able to go in the box.
Oh, yes. The blue ones can also go in the box as well. This is just a practice run. You know, we were just practicing with the yellow one. This is not an actual competition. We set up like a faux arena in the robotics room at school.
Well, you have a pretty big classroom.
Yeah.
Mm-hmm.
Did you guys have like a project manager to build a schedule and organize everything to stay on track and be able to, have a working robot when it was time to go to competition?
Yeah. Well, we meet up like, what was the schedule? It was every day.
Except Fridays.
Hang on. I gotta chat answer this. Okay, so yeah, we tried to meet every day except Fridays. Or if someone couldn't make it, then we just, as we tried to make it as many times as we could be there, except Fridays, to practice and work on it. Whoever could be there could be there. Whoever couldn't be there couldn't be there. But I do think it let us get a lot of practice in, and it let us get a lot of build time in, and a lot of hours in.
We just learned also how to drive.
How many weeks overall was the building of the robot before you had to finalize it to send it to competition?
When did we start? October?
They introduced the game at the beginning of September, and then our first qualifier tournament was the end of October. And then our second one was the end of November, and then our third tournament was mid-December. So you kind of have some points, some deadline points. You need to have a working robot by the end of October, and then you can make improvements throughout the rest of the remaining weeks.
Cool.
Going back to the question about the processor, I don't know this for certain, but I believe it might be a BBC microbit, because the blocks language is advertised as one of the languages that is available on that particular platform, and that's the language that's used in this competition.
This question is kind of for Jacqueline. Is how did you like putting together the notebook, and what did you find challenging in doing that?
Could you repeat that?
Sure. How did you like putting together the notebook for the team, and what did you find most challenging about that?
Well, the most challenging one was probably getting design ideas, but my team members helped me out by like giving me ideas and like examples on what to do, making the notebook together.
I think it's definitely one of our areas of growth for next year, because they do expect you to have a fairly complete engineering notebook, which I don't know that we had the technical bits especially very well fleshed out.
Yeah.
Uh-huh. Thank you.
Mm-hmm.
Was the green light on the robot just to show that it's powered on, or was that changing due to direction or motion or anything of that nature?
No, it's just on.
Mm-hmm.
Red light bad. I guess it's more of amber. Green is on and connected, I think. Or blue, and sometimes it's blue too.
So when the robot is hanging, at the end of the competition, when you're trying to get it hanging from the hook, is the hook just hooking on one of the bars that you were putting the specimens on, or is it a different bar? It almost seems like there's only one bar it could reach where it could lift the robot up, or you could get it on there. Is that correct?
Never fear, it's a different bar. Chris, could you go back to the slide that shows the arena? There it is. Yeah. See? You see the two long metal bars?
Okay. I see.
And the blue and the red ones are just PVC.
Yeah. Those would break if we hang on it.
Right. So you actually have to get the robot completely off the ground when you're hanging on the hook, or just get the hook on there?
There's 3 levels of ascent, and each one gets you more points than the last. The first one is just touching the bar. The second one is hanging off the lower bar. The third one is climbing the first bar, and you have to be fully elevated in an ascent level 2. And then you have to go from a 2 to a 3, which is hanging off the higher bar.
Wow.
We didn't see anyone do that. Did we see someone do that? I think we saw. No, we didn't see anyone do that.
I don't think anyone in our region did that.
No.
Everyone we asked about it, like everyone. Yeah, I don't know.
Yeah, that sounds pretty tricky.
And there's not much time. You only have 30 seconds to do all of that, and it's not a lot of time. Yeah.
Usually it's the part of the game where I would say that there's the highest rate of failure, as you have to carry the whole way, and we try to go for a lighter design.
Yeah.
So we could, if we attempted to hang, but we decided to just at the end see if we could score one more specimen. And usually we could do one, hang one more for the final point during those last 30 seconds, and then we went over to the side to touch the bar, which I would say is about equivalent to getting a higher rung. So I believe it's just more efficient that way.
That sounds like quite a competition. Did they have a storyline analogy on the competition itself? Is like is this simulating capturing sea creatures with ROVs kind of situation? Is that what they were framing this around?
So you're asking if there's lore? I don't think there's lore.
Yeah, the theme changes every year.
I mean, there's a theme, but like it's very loose, you know? Like in no way would I would clip things onto sea creatures and then hang them on a thing.
Well, they are card samples and specimens.
But yeah, the concept is they're ROVs doing underwater sampling.
It's called Into the Deep.
Yeah.
Right. Yeah, I imagine. I mean, the parallel that would be your samples and your specimens would be in containers or something else that you're capturing them with. They created the objects just as a placeholder for what the real action would be. Certainly, they'd be, most sea creatures are pretty delicate and they're not going to handle being grabbed by a robot gripper very well.
Oh boy.
And survive. You might get them, but they won't necessarily survive.
Unfortunately, she's not here, but Aaliyah, her class I took to the Mass Center, which is the aquarium down at Redondo, and it's run by Highline College. And they have some school programs, and we did their ROV program, and they had to build ROVs out of PVC pipe and motors tethered that scooped rocks and then brought them back to the surface. And this is supposed to be something similar to emulating that.
Very slick.
Sounds awesome.
Yeah, it's a super cool program.
In the little kid version, the elementary version of this year, I help out with the elementary side. They call it Submerged. And the kids had to do a presentation on like some sort of technology. I think the kids that I was with, they did something on like coastline erosion or something. Did you guys also have to do like a presentation that went along with this?
Yeah, we did.
We had an interview.
We had like
they don't have to do the research component like an FLL though. They just have to present on their robot and their team.
Gotcha. Cool.
Yeah, it was just an interview.
Ours is surprisingly short, I feel like, compared to other teams.
Well, I think that's because we gave the best answers.
Exactly.
I'm sure.
But that's the point of the engineering notebook, is that you're focusing more on the technical and the you're supposed to do the business component and fundraising and all that, and how is your team functioning in that regard, rather than doing the solving a problem, engineering design challenge kind of thing.
Yeah,
So
I found they did project management. That was a big component for the FLL. And I asked the question about that because I think, as somebody that does amateur robotics, I find that's sometimes part of the hardest part is like setting up, setting milestones, ordering the right parts, or doing the code and testing to make sure it works before you build something around something. I feel sometimes that's the hardest part of building robots.
Yep.
But Terry, I interrupted you a bit.
Oh, it's quite all right. I was just thinking, at this point, are you pretty much done with the competition phases of competition, and now you're looking toward what are you going to do for next year and how to build your team out for next year, or where are you at?
We're at exactly where you said.
Okay.
It's the off season. Did you keep track of the costume of the robot? Well, okay, Craig Austin. We get like a grant, we get like a grant, and the grant gives us, how much money does it give us, Mr. Rice?
I think it was 2,500 this year, and it's a grant through OSPI, the Office of Superintendent of Public Instruction, and that's funded through the legislature. So thank you, legislatures, for passing that robotics funding grant.
Yeah.
Because that's how most of the teams get their funding.
Yeah.
And then we also got a donation from a local business, Exotic Metals, of $1,000.
Exotic Metals. Coda's.
And then TAF, which is the nonprofit that co-partners with our school, also contributes to our registration fees.
And TAF stands for?
Technology Access Foundation. It's a nonprofit out of, I think they're based in Burien, White Center. And then they co-manage a few schools in the South Sound region.
Cool. So do I see 3D printed parts on the backside in the right-hand picture?
Oh, you sure do. You sure do.
Who got to play with the 3D printing and make those parts work?
Talk about Colton. He's one of your mentors.
Oh yes, Colton. Colton made this, didn't they? Colton made this, right? Colton, I think the black parts are stuff we used last year. And we also used the purple parts last year. But they're still 3D printed. They're still made of beautiful plastic. Okay, I guess that.
Kai, maybe you could talk about the makerspace.
Oh yeah. So why am I talking? You should talk about the makerspace, Cody. You're the one that runs it.
This is a student presentation, Kai. This is good for you.
All right. Basically, so if you want to know what Coda does, in our school, we have a makerspace. You guys all know what makerspaces are, yes? Yeah?
Yes.
Everyone knows it. All right. So basically, Coda has one. It's got like 3D printers, laser cutters, sewing machines, computers. What else does it have? It has soldering irons, stuff like that,
Sewing machine?
I said sewing machines already, Luis.
Oh. I just love those sewing machines.
Yeah. And anyway, Colton 3D printed. I don't know if Colton has his own 3D printer or
Colton does.
Colton does have, Colton's just that kind. Yeah. So anyway, Colton made those. I think, and you see the 7732? That was 3D printed in our very own Loverly makerspace. Was it printed in the makerspace?
Yeah.
It might have been printed in Mr. Reiser's room. I don't know.
No, I think Coda printed those.
Yeah, Coda did that.
Cool.
So, and then we stuck it on the robot, and because you need to show its number. That's the one.
Kai, you made a very nice number plate for us this year, and then they told us it was illegal.
Oh
so
yeah, I forgot.
No.
It was really nice design. It was beautiful.
I was really, really mad.
That's a bummer.
But they wanted just the standard block numbers like that.
Because they're stupid and boring.
Art versus science there a little
exactly.
bit.
No, that's how we felt too.
But,
function versus form.
Yeah, STEAM versus STEM.
Censorship. It's censorship. They just don't like it because it was too good.
I'm a STEM major. Why should I have to think about making it look good,
Anyway.
It works.
Anyway, 3D printing parts, super helpful. except when they break. That sucks. But you just put it into places where it doesn't break, so it's okay. We also 3D printed some of the samples to help us practice with, because they didn't give us any, right? We couldn't.
We had to buy them, but they were super delayed funding, so we
yeah.
We had to make them.
Our school, they don't. It's hard for us to get the funding.
Well, they just
sure.
forgot to send us the check.
It's
like,
the what?
Was sitting on. They didn't send us the check. It just was like sitting on someone's desk in Olympia.
Yeah. No, that's a practical solution though, as an alternative. Bravo.
Mhm.
Sometimes that's what you have to do when you're waiting for the things that you need, is to find a way to pitch it and work around your limitations. I think John had a question in the chat.
John, are there restrictions on what you can or can't use on the robot? Yes, there are. Yes, there are, John. What was the learning curve like to grip the samples?
Oh, to answer the restrictions questions, they dictate what motors and controlling systems you can use. But for infrastructure of the robot itself, like as long as it's like you can pretty much use anything off the shelf or manufactured in shop.
So Doug asks, what was the learning curve like to grip the samples? There wasn't really a learning curve, because like when you pick up stuff, you have to keep putting like pressure on it. When you grip something between two fingers, you have to keep putting pressure on it, or else it's gonna fall out your fingers. You have to consciously do that. But with the servos, they just like you press a button and they're just gonna stay at that distance. They're just gonna stay gripping it. So, we just had to line ourselves up right. It's not that hard once you get the hang of it. Maybe took me like a day to get down. I don't know.
I can answer Chaz's question. Our school kind of format. So it's always a little complicated because it's TAF at Saghalie. So we're a traditional public school, neighborhood school, sometimes they call it, for 6 through 8. And then we're a choice high school, which is 9 through 12. So a lot of our middle schoolers end up going to the traditional comprehensive high school once they get to 9th grade, but some of them choice in, like Kai and Luis and Jackie, and stay at our school for 9th through 12th grade. And so, yeah, we're not a public, or we're not a private or a magnet school or anything like that. We are a traditional public school. We just get extra funding and extra staffing through TAF, which is our nonprofit that co-manages. Yeah, I think it's a really good system. That's how we have Coda and the Makerspace, for example.
Yeah,
I went to Kylo and TJ, and then I did get to go to the Highline. What do they call that? CTAC Skills Center or something like that.
Skills Center.
ESSC.
That's awesome.
Yeah, they changed the name like back in some time ago. I went in '94 for high school, so that when I graduated, so it's been a while. But
so a lot of our students will do that. They'll do 9th and 10th grade at our school, and then they'll do half-day skills center for 11th and 12th grade, for example, or Running Start, for example.
That's awesome.
Yeah.
You guys got any more questions?
What do you guys do for, do you engage in fundraising throughout the year to try to help build up your funds for the following year? Or is it pretty much just, working from the grant for your funding?
Well, this is a complicated question. So all our fundraising has to be routed through either the PTA or the ASB. And our ASB is kind of like gone right now because the teacher got like transferred to another school against her will. So, they took away the the ASB teacher, and then they haven't really got it back up and running. So
there is still technically an ASB.
But
The forms still do have to go through it, and I have to sign off usually, as I am the school president. So yeah, sometimes I just get forms handed to me, which I and the principal, I believe.
Wait,
and
what?
Our school financial.
Wait, what? Wait, you are? Oh,
yeah.
Okay. Anyway,
surprise.
I really do not talk about this because
talk about this.
no one brings it up usually.
Well, okay.
Yeah, I was just wondering, like for, your team shirts and other things you might be putting together, if they didn't, you wanted to do things above and beyond what the grant would fund. I seem to remember talking to some other teams where, but I'm not sure if it's at your level, where they would do fundraising throughout the year, as they could do presentations and fundraising of different kinds, just so that they could bank money for the following year, to be able to help out, and to be able to, I think, to travel if they ended up going to the higher level competitions.
Yeah, especially the next level FFRC is a much bigger cost. Our cost needs are about 5,000 throughout the year, travel included, which the grant and sponsored fundraiser or sponsorship through local businesses pretty much covers. We should do some more fundraising just as like team building activities, probably, but
team building.
That could be kind of fun. Maybe that's something we practice or plan on here in the spring.
Yeah, I would also mention about like the shirts and the hoodies that we have, because we have access to resources. Yeah. Because we have like the makerspace and the art classroom, we actually made these hoodies ourselves.
Oh, outstanding.
Yeah, so Jackie did most of the designing for the logo.
Yeah.
She made the incredible sea wolf.
Yeah, and she had to thread
really
all the get all the
7732
vinyl unstuck and printed on. Yeah, it's a lot of work to make those T-shirts.
It was a pain.
And the one I'm wearing is our logo from last year.
Yeah,
because we had a different mascot last year.
Yeah. We decided to go with our theme, with Into the Deep, so we called ourselves the TAF Saghalie Sea Wolves.
Yeah, the artwork on your logo is fantastic. It reminds me of Balto, from I think it's a Disney movie. But yeah, if she drew that, she's got a really great eye, and
I think she used a little bit of generative AI and then kind of traced around it.
Yeah.
Okay.
Wait.
She did design the original concept.
Jackie designed the original concept.
Yeah, I did.
But
still a nice product. It turned out well.
Thank you.
Bolt? The Disney movie. Are you talking about Bolt?
No,
before Bolt, there was one called Balto.
I don't know.
Have you never seen Balto? Oh, you should watch Balto.
A wolf.
Balto was a wolf.
He had to deliver the medicine in Alaska.
Oh. How old is this?
90s.
Oh, it's named after a dog.
Oh.
Oh man.
It's going back. Yeah.
It's not Despicable Me. They don't know.
I don't know.
I like Bolt, however, just to let you know.
Okay.
That was also
a
fun.
great movie.
Terry Our Age, Terry, way back in the 1900s.
Yeah.
I saw Balto in theaters, so.
There's this new series called Snow White.
Oh my god.
Not that old.
Have I been sideways this whole time?
No, you were right to begin with.
Okay, cool. Anyway, do you guys have any other questions?
So how many of you plan to study robotics after high school?
Study robotics? Like, okay. Luis, you said you were
Luis is a senior,
yeah. So I am going into UW for computer science. It's not exactly a robotics field, but I do believe a lot of technical skills could transfer it back into robotics, as you do need to program. I would say I had passable code, but I think I will be able to supercharge my abilities the upcoming years. And then maybe, who knows, maybe it could be a mentor and help out the next generation of a robotics team.
Absolutely. Good idea.
Okay.
Anybody else headed for any science or engineering type roles, or
I'm
what do
going.
you consider?
I'm gonna.
Are you doing Running Start next year, Kai?
Yeah, but for therapy. So yeah. Okay.
Okay. Well, thanks for your presentation, guys. I appreciate it.
Yes, thank you. You did a great job.
Yeah, thanks for having us. They are part of their robotics. You know, they're supposed to be doing outreach, so this is a really good opportunity for them to get all those things in too. So thank you for allowing us this opportunity.
Thank you.
Excellent.
Very welcome.
Pretty good team building as well.
Thank you.
Yeah.